All right, let's start. So last week, we connect the short run cost curves to the long run cost curves. So this is where we stopped last time. And we said that if this is the short run average cost, and we know that in the short run, capital is fixed. So if this is the short run average cost based on this much capital, K1. So in the short run, capital is fixed, which is like the factory size. So for this factory size, this is the short run average cost. So if the firm is going to have a larger factory, then the short run average cost may be lower. So if the firm is having a larger factory, more machines, then to produce a larger quantity, the cost per unit may be less than a smaller factory with fewer machines. And somewhere in between, there may be another factory size that based on this much capital. And if the firm has time to choose any factory size it likes, then the question is, which factory size would this firm choose? Well, the answer is simple. It's actually a question. That is, how much does this firm plan to produce in the long run? Because if the firm plans to produce this quantity in the long run, then it would find a factory size that would produce this level of output at the lowest cost, like this. And if the firm plans to produce this level of output, then the best factory size will be this one, because this is the lowest cost per unit to produce this level of output. And imagine, if the firm has time to choose a factory size, it can pick any size it wants. Then we will have a graph like this, the one that we had last week. So many different sizes of the factories that this firm can choose. And the firm will always choose the one with the lowest cost for that corresponding level of output. So in other words, the long run average cost is simply the lowest envelope of the collection of all the short run average cost curve. In other words, the long run average cost is also a U-shaped cost curve, but this is more mildly sloped than any individual factory size, because this is the collection of all the short run average costs with the lowest point for any particular level of output. Now, that's where we stopped last week. The next question is, now we know that the long run average cost looks like a U-shape. So what we have in here is that in the long run, At this level of output, raising production of the output, the cost per unit drops. As we move here, what do we see is larger quantity of outputs produced implies larger scale of the operations. The more output the firm produces, that means the larger the factory size will be required. And this is like changing the scale of operations. And the cost per unit drops. And we call this economies of scale. That is, as the scale expands, the cost per unit drops. So that is some gain in terms of efficiency. And that's why the cost per unit will drop. But beyond a certain level of output, if the firm continues to expand its scale of operation, then the cost per unit will start to rise. This is the diseconomy scale. And now, economies of scale, cost per unit drops. This is also associated with increasing return to scale. That is, if you double the inputs, double the outputs, then the cost would not be doubled. And therefore, the cost per unit will drop. That is increasing return. As you double the input, you get more double the output. At this stage, when the cost per unit goes up, the diseconomies of scale, then this is the decreasing return to scale. That is, when you increase all the inputs proportionally, the output would not increase by the same proportion. As a result, the cost per unit would increase. So in the bottom here, this is the constant return to scale. That is, around this neighborhood, you double the inputs, you double the outputs. And the cost per unit pretty much remain the same. As you double inputs, double cost, you also double the output. And therefore, the cost per unit pretty much the same. And now, why do we have economies of scale? And why would we have these economies of scale? Economies of scale. One reason for that is that larger scale of operations permit flexibility. For example, cross-training. as backup. So when you have many workers in your factories, then each worker may learn the task of another worker as a backup. And therefore, if one day one worker is absent from work, another worker can fill that spot. So the production will not be stopped or slowed down. Another reason is specialization. With large-scale operations, the firm can now cut the tasks into much smaller ones, and workers doing the same task day in and day out will find better way to do the job faster and with higher quality output and less defects. So that is the idea behind the assembly line. And also, buy in bulk discount. On inputs. That is, the more inputs you use, the more you produce, the more bargaining power for the firm to negotiate with its suppliers to get a better deal on inputs. And that helps reduce the cost. And now, what about these economies of scale? So if increasing the scale of operations, the firm will have this flexibility to lower the cost per unit. Then how come in the end, the cost per unit will rise? One reason for that is beyond a certain scale of operations, monitoring workers becomes expensive. So when you have a small factory with only 10 workers in a garage, for example, you can see all the workers, what they are doing. You can monitor whether they are shirking or not. But if you have a huge factory with 10,000 workers, then it will be difficult. Monitoring. So if you have a factory of 10,000 workers, it will be difficult for anyone to see all the workers, whether they are working or not at the same time. So monitoring will become expensive. For example, you have to install CCTV to monitor workers, or you have to hire more supervisors to supervise your workers. And sometimes you may also need to have GPS to monitor where the workers are. Make sure they're in the right place doing their job instead of fooling around. And all these will add cost to the firm. Another reason why firms will experience these economies of scale beyond a certain scale of operations is that management hierarchy. Slow down communication. And reducing flexibility. Now, for example, using our 10 workers factory example, if, let's say, in a 10 worker factory, the printer in the office broken down, no problem. The owner is there. And then you can ask the owner to get a new printer from Staples, like 30 minutes, driving to Staples, get a new printer back to the factory and install it, if this is a small factory. But if this is a big factory, then you will have to go through all the administrative details. That is, if you want a new printer, first you have to file a form to get the department head approval. And then after the approval, they will check the budget for the department. And if everything is fine, then the procuring department will send the order to Staples, and Staples will deliver that to the company, and the company will send it down to the department. Instead of 30 minutes, now it becomes several days. And that is slowing down communication, decision-making process and timing, and reducing flexibility. All right. So now, this is all we need to know for the cost between long run and short run. Next, chapter 12. Now, first, chapter 12 is talking about perfect competition. What we will do in this chapter is first to help us define the profits maximizing rule for the firm. That is, what will be the condition to define maximum profit for the firm? And then we will look at the outputs and profits, and the supply decision. In the short run. And then we will get the industry supply in the short run. That is, from the firm level, about profit maximizing rule. And then we will talk about the output and profit. That is, how much the firm would want to supply in the short run. And then combine all the firms in the industry to get us the industry supply in the short run. And then last, we will look at the long run supply in a perfect competitive market. So that will be the flow of this chapter. And now, perfect competition. The conditions for perfect competition to exist. First, there must be many buyers and sellers. So in a market with many buyers and sellers, that means buyers are competing against each other to buy the product. Sellers are also competing against each other to sell their product. And in this situation, none has any influence on the price in the market. Now, for example, you are just one of the million consumers in the market to buy breakfast cereals. If one day you decided to stop eating breakfast cereal, would it affect the price of breakfast cereals in the market? Of course not. Or if you were one of the many farmers selling eggs in the market, and one day if you decide to retire, will you withdraw from the market? Would the price of eggs in Canada be affected? Of course not. So in other words, with or without a particular buyer or seller in the market, the price would not be affected. And therefore, every buyer and seller must take the price as given and respond the best they can. So in other words, this is the idea behind supply and demand curve. The supply curve tells us at different prices what will be the best response for a firm to supply the output to the market. The demand curve tells us at different prices what will be the best response for a particular consumer to buy the quantity that will make this consumer the happiest. Now, only under perfect competition we will have a supply curve, as you will see in the next 3 chapters, chapter 13, 14, and 15. We don't have supply curve for the sellers. Only in perfect competition, when they take the price as given, and we would have the supply curve. Because when they don't have any impact on the market, means they have zero market power, which implies they are the price takers. Price takers, they respond to the price because they have no market power. In the next 3 chapters, firms, they have some market power or more market power, then they set the price instead of responding to the price, and that's why we won't have supply curve. Next, the second condition for perfect competition to exist is perfect information. Why it is necessary? First, the buyers won't be fooled by sellers. Now remember, the sellers competing against each other for customers, the buyers, and they may promote their product as the best product, the lowest price on the market. But the buyers are not dumb. They know exactly what the sellers sell and where they can find the product at the lowest price in the market. So this is what perfect information is for from the buyer's perspective. That is, They can always find the best price in the market, and they won't be fooled by any attempt of the sellers when they try to fool them into believing the sellers are selling the product at a lower price than the others. Now, for the seller's perspective, with perfect information, sellers always get the most efficient technology to sell or supply, and therefore none has cost advantage over others. So this is what perfect information will do from the seller's perspective or from the firm perspective. All the firms know exactly how to produce this good at the lowest possible cost, the most efficient way, in order for them to survive the competition. If you using the same technology as everyone in the industry, that means you must have the same cost as everyone in the industry. And therefore, they cannot have cost advantage, and they cannot kill any of their competitors. As a result, they must coexist. And that's why there are so many sellers, because they all being identical in terms of efficiency. If you are not efficient, you wouldn't be able to survive. This is like the jungle rule, the survival of the fittest in this industry with so intense competition. Now, what's before perfect information? The first assumption was many buyers, many sellers. The third one is that buyers treat products of all sellers as identical. That means, in other words, it doesn't matter how hard the sellers trying to promote their product as better than the others, but to the buyers, all these products from the sellers in this market are identical, and they are from firm A or buying from firm B doesn't really matter. It's identical product. Now, what is the implication of this assumption? That means the product of any particular seller has numerous perfect substitutes, because there are many firms, and if all these firms are selling identical products considered by the buyers, then if you were one of these many firms, your product would have many perfect substitutes. And later on, we would use this implication to help us figure out the revenue for the perfectly competitive firm. The last assumption or condition for the perfect competition to exist is that there will be no entry or exit barriers. So in other words, Firms can enter or firms can leave anytime they like if they have sufficient time to adjust, to enter or to exit an industry. There's nothing that will prevent them from entering or prevent them from leaving the industry. And now, with these 4 conditions, like someone asked, is perfect competition theoretically possible, but in reality, it's impossible? The reason is here. First, it is difficult to find identical products if we consider the product as a package, that is not just the product itself. Now, for example, Toronto Sun. You buy the Toronto Sun in Scarborough. It's the same Toronto Sun that you buy in downtown Toronto. But if you consider the location and where you live, then the Toronto Sun in Scarborough will be different from the Toronto Sun in downtown Toronto, because you just walk down to the street and go to the nearest variety store and you can buy the Toronto Sun. Convenience, very close. Compared to going all the way to downtown to buy the same Toronto Sun, they are not the same. So when we factor in all the required process to get the product, we don't have identical product, especially when we also consider location. In other words, in reality, we don't have perfect competition. And then you will wonder, if perfect competition doesn't exist in reality, are we wasting time? No. Perfect competition, as we will show by the end of this chapter, is that perfect competition will give us the most efficient outcomes. Now, even though it doesn't exist in reality, but it does provide us with the benchmark to measure efficiency, so that we can use this benchmark to compare to other market structure like monopoly, oligopoly, monopolistic competition, to see how efficient or inefficient of other types of market structure. And now, next, profit is equal to total revenue minus total cost. So if we want to figure out the maximum profit, first we need to understand revenue and cost. Well, last chapter, chapter 11, we took care of the cost. We studied the cost curves. And now, revenue. Now, revenue will depend on the market structure, because different market structure would result in different revenue for the firm. And now, under perfect competition, what do we know is that a firm's product has numerous perfect substitutes. And now, this is our third assumption. How would it help? We know increasing the number of substitutes will increase elasticity and flatter demand curve. Something we learned from the elasticity chapter. And when there are many perfect substitutes, this elasticity will become perfectly elastic. With perfectly elastic demand, the demand curve for any particular firm in the industry is actually a horizontal line. Now notice that I'm using lowercase. That means for a particular firm, not for the entire industry. So this is the demand for a particular firm in the market. This is the output of a particular firm in the market. So because with so many perfect substitutes, the demand for a firm's product is actually perfectly elastic. That means the demand curve must be horizontal. For a particular firm's product. Now with this horizontal demand curve, what we see is that, for example, if this is at $5, then 1 unit, 2 units, or 3 units, it doesn't matter how many units, it's always at the same price because this demand curve is horizontal. Then, from this, what we can see is that if output equals to 1 unit, the total revenue equals to $5. It is equal to the price times quantity. 2 units, $10. 3 units, $15. And from this total revenue, we can derive the average revenue, which is equals to the total revenue divided by the output, which is equals to P times Q divided by Q is simply P. That is 5 divided by 1 is 5, 10 divided by 2 is 5, 15 divided by 3 is also 5. And now, marginal revenue. The marginal revenue is equal to the change in total revenue, the change in output. So from 1 unit to 2 units, the change in total revenue is equal to 10 minus 5. And the change in output equals to 2 minus 1. And therefore, from the first to the second unit, the marginal revenue is equal to 5. From 2 to 3, it is also equals to 5. So in other words, when we have a horizontal demand curve like this, the special characteristic about this horizontal demand curve is that price equals to average revenue equals to marginal revenue. And now, the profit maximizing output. If profits, we use pi as a symbol, equals to total revenue minus AR is average revenue. Yes, that's correct. Minus total cost. Then the change in profits must come from the change in total revenue minus the change in the total cost. Because what changes on the left-hand side must equals to the changes on the right-hand side. And if we divide by the change in the output, what do we see in here is that marginal revenue minus marginal cost. So when the firm is changing its output, the impact of the change in the firm's output on the firm's profit depends on the marginal revenue and the marginal cost of that additional unit of output. For example, if increased output by 1 extra unit where the marginal revenue is greater than marginal cost. In other words, producing 1 more unit, this extra 1 unit of output will bring in more revenue for the firm than what it costs the firm to produce this 1 extra unit. If that is the case, then the profit would rise. For example, producing that 1 extra unit, it cost the firm $7. But selling that 1 extra unit, the firm will generate $10 revenue. When we compare these two, then the profit must be rising by $3. So if selling this 1 extra unit would help the firm raise the profit, then the firm would produce this extra unit. And the reverse is true. If that 1 extra unit is going to cause the firm to lose money, the firm would rather not to produce that extra unit. And now, we learn about the equation. We learn about the intuitive reasoning. Let's see it visually. So in chapter 11, we learned that the marginal cost looks like this. And if this is the market price, which is the marginal revenue, if the firm is here producing output Q1, Should the firm produce this output? Should the firm increase output? Or should the firm decrease output? Well, at this level of output, the marginal revenue is greater than the marginal cost. And what do we learn from that? When marginal revenue greater than marginal cost, the firm should increase output. That is, producing extra units of output would have positive contribution to the firm's profit. In other words, the firm should be producing more output. If the firm is producing this quantity, Q2, in which marginal cost is greater than marginal revenue, well, we proved that marginal revenue equals to price because of the horizontal demand curve. About 10 minutes ago from this graph. So if the firm is producing this level of output, where the marginal cost greater than marginal revenue, that means this unit is money-losing unit. The firm should cut back this unit to cut loss. That means the firm should be reducing output. And now what do we see? Looks like there's some kind of gravitational forces to bring us to this point where marginal revenue equals to marginal cost. Increasing profit, cutting losses. So this must be the point. The firm can actually maximize profits when marginal revenue equals to marginal cost. And now, looks like we are overlooking something. Last week, when we look at the marginal cost is actually U-shaped. Marginal revenue equals to marginal cost is zero profit for the last unit, not all the units. Remember, this is about marginal, not overall, not total. So, if this is the price, in other words, it is not per unit, it's just the last unit. Per unit is the average. Earlier, we said that this is the point where marginal revenue equals to marginal cost to give the firm maximum profits. But looks like we have another point in here that is also marginal revenue equals to marginal cost. Why no one pays attention to this intersection? Everyone only talks about this intersection. What's wrong with this? Not smaller profit. Now, let's start from the first unit in here, all the way to this level of output. What do we see? From here to this level of output, marginal cost is greater than marginal revenue because marginal cost is up here. Marginal revenue is down here. So if we extend the marginal cost curve, that is the loss from all these initial units when the cost at the margin is greater than the revenue at the margin. So all these units are money-losing units at the beginning. So if the firm stops here, the firm will only be losing money, for sure. But if the firm continues to produce beyond this level, these units are profitable units because the marginal revenue is greater than the marginal cost in here. And if the firm wants to make some profits, the firm must capture all these potential profitable opportunities. Hopefully, this will be enough to offset the initial loss and leave the firm with some positive profit. And that's why, if the firm stops here, the firm will only be losing money. If the firm stops here, it is possible the firm may be making positive profits. And that's why we always ignore the intersection on the left. We only look at the intersection on the right. That is when marginal cost is rising, not when marginal cost is falling. All right, let's take a 10-minute break. Okay, let's start. Before the break, we have explained that profit maximizing outputs is where marginal revenue equals to marginal cost, and marginal cost is increasing. That is the intersection on the right, not the left. So we complete the first step, that is to figure out the profit maximizing level of outputs. That happens when marginal revenue equals to marginal cost. The next question is, how big is the profit? So we have figured out the profit maximizing output, and then we need to figure out how big is the profit. So now, if this is the marginal cost, and this is the short run average cost, then, for example, if the price is here, this is the price in the market, P1. And we know that the profit maximizing output is where the price, which is the marginal revenue, is equal to the marginal cost. So this must be the output that the firm is maximizing profits. And the next question is, can we figure out the profits from this graph? Of course we can, but let's look at the expression, the definition of profit. Profit equals to total revenue minus total cost. Now, average revenue is equal to total revenue divided by quantity. In other words, average revenue times quantity equals to total revenue. And for perfectly competitive firm, average revenue is price. And price is given. Next, the short run average cost is equal to the total cost divided by output in the short run. And therefore, the short run average cost times output equals to the total cost. And now profit can be written as price times quantity minus the short run average cost times quantity. And that gives us price minus short run average cost times quantity equals to the profit. Now this is the general expression. Let's get this general expression into our specific example output, Q1. So in this example, what do we have? The profit is equals to the price, which is P1, minus the short-run average cost, that is producing this output, Q1, according to this short-run average cost curve. This would be the short-run average cost. So price minus the short-run average cost at this output level, multiplied by the output Q1, which is exactly what we defined earlier. Profit equals to price minus short-run average cost times quantity. But we apply this to this specific level of output, price and short-run average cost. And now, what do we see in this expression is that this one is the height, which is this. And quantity is the base, which is this. So how big is the profit? It's the area of this rectangle. Height times base defines the area of this rectangle. And this is how we can figure out the profit visually in this graph. The height is actually what we call the profit margin per unit. If this is the price the firm receives for every unit, and this is the cost per unit for the firm to produce this output, the difference between the price and the average cost is actually the profit margin per unit. If you multiply the profit margin per unit by the number of units, that gives us the total profit. So when the price is P1, the firm will produce Q1, and this will be the profit. And now, marginal cost and short-run average cost together, well, they're always together. Remember last week, we derived a set of cost curves. Marginal cost, short-run average cost, and also average variable cost. We will bring that in later on. And now, if the price drops to P2, and according to the profit maximizing rule, the firm would produce this level of output, Q2, and this will be the short-run average cost. And therefore, the profit is this rectangle. Now we learn the approach to figure out the profit maximizing output and to figure out the size of the profit. And what do we learn from these two simple examples? When the price drops, the firm is producing a smaller quantity. Why? Well, because the profit drops. Look at the green shaded area with the higher price. That is a much larger profit than the profit the firm earns when the price drops to P2. The price drops, reducing profits, less incentive to produce. The firm is offering a smaller quantity to the market. And now, this graph is messy. So let's get the same graph, but removing some of the areas and lines to make it look cleaner. When the price is P1, the firm would produce Q1. When the price drops to P2, the firm would produce a smaller quantity, Q2. And now, if the price continues to drop to here, to PB, then the firm would produce this level of output, QB. Now, why I call this B instead of 3? Because this is the break-even price. In other words, profit is 0. The reason is the price is equal to the short-run average cost. In other words, the firm is exactly receiving this much per unit, which is what it costs the firm to produce each unit. So the firm is not making any economic profits. So that's why we call this the break-even price. And now, what if the price continues to drop like this? If the price continues to drop to P3, this will be Q3. And now, what do we see? That would be a loss to the firm. That is, if the price drops below the break-even price, the firm will be losing money. And what should the firm do? Now, if you ask 100 people on the streets with no economic background, more than 80% of the people would tell you, if the firm is losing money, close the door. Well, sometimes they may be right. Sometimes they may be wrong. For us to figure out whether this is the correct decision to close the door, like shut down, in the short run, we need more information. Now, if we look at these cost curves, something is missing. Last week, we had the average variable cost, and now it is time to bring the average variable cost into the picture to help us figure out whether the firm should continue to produce or the firm should shut down if it is losing money in the short run. So this is the marginal cost, and this is the average variable cost. And this is the short-run average cost. And now, the price P3, suppose is here. And the firm is losing money. So this is the loss. Should the firm produce? Well, to some people, it is difficult to call, but to us, we need to lay down all the options for the firm. That is, profit equals to total revenue minus total cost. And in the short run, total cost has two components, fixed cost plus variable cost. That is total revenue minus fixed cost minus variable cost. That is profit. This one, if the price is here, price equals to marginal cost. We know that price also equals to marginal revenue for a perfectly competitive firm. And therefore, the firm will produce this level of output. But at this level of output, the cost per unit, according to the short run average cost, is here. That is, every unit, it will cost the firm more to produce than what these units can bring for the firm as revenue. So the firm is losing this much money if the price drops to P3. And now, back to here. If shut down, output equal to 0. So shut down means close the door. No output, no revenue. No output, no variable cost. So this is 0. This is 0. In other words, the profit is simply negative fixed cost. That is, if the firm shuts down in the short run, the firm will be losing the entire fixed cost, because fixed cost is what the firm must pay, whether the firm produces output or not in the short run. So if the firm is shut down, the firm will lose the fixed cost. And how can we figure out the fixed cost? Well, we know average fixed cost equals to fixed cost divided by the output. And therefore, the fixed cost is equal to the average fixed cost times the output. We know the output, but we need to figure out the average fixed cost in the graph. And it goes back to what we discussed last week. The total cost equals to fixed cost plus the variable cost. And if we divide everything by output, then in the short run average cost is equal to the average fixed cost plus the average variable cost. In other words, short run average cost minus average variable cost is equal to the average fixed cost. This is the vertical distance between the short-run average cost and the average variable cost. And now we know how to figure out the average fixed cost in the graph, which is simply the vertical distance between the short-run average cost and the average variable cost. And now we can go back to the graph. At this level of output, the average fixed cost is the vertical distance between the short-run average cost and the average variable cost, and multiplied by the quantity. This red rectangle is the fixed cost. And now, what do we see is that if the firm shuts down, the firm will lose the red rectangle. If the firm continues to produce, the firm will lose the green shaded area. Now, in the business world, if the firm can make profit, the firm would want to make as much profit as possible. But if the firm must suffer a loss, the firm would want to cut the loss to as little as possible. So in this scenario, two choices: to lose the entire fixed cost, shut down, or to produce and lose less. Well, to produce and lose less money is a better choice. And therefore, even though the firm is losing money, the firm will still continue to produce. And that's why I said earlier, sometimes losing money doesn't mean shut down. In this case, continue to operate would actually help the firm lose less money. And now, if the price continues to drop to this new critical level, this is S. That means the shutdown price. In other words, if the price drops below this level, PS, which is the minimum of the average variable cost, then the firm should shut down. So this is why it is a critical point, because this is the point at which the firm should remain open. The lowest price point for the output, the firm should remain operating. Anything below this, the firm should shut down. That's why we call this the shutdown price, because below that, the firm will shut down. Why? At this level, PS is equal to the average variable cost. This is the shutdown price. And also this is the minimum of the average variable cost. No, even if the price is a shutdown, that is, the firm will be indifferent, shutting down or not. But typically, we would assume the firm will continue to operate at the shutdown price. The reason is, if the firm actually shut down, it may be difficult for the firm to hire the workers back when the market recovers. And that's why, even though it's indifferent, but we would like to assume the firm will continue operate even at the shutdown price. But if the price is less than the average variable cost. What does it mean? Well, let's do the trick. Multiply both sides by the output. And this is the total revenue. And this is the variable cost. And in the short run, variable cost is the labor cost. Because in the short run, labor is the variable input. And therefore, to pay for the cost of the variable input is the variable cost. So if the price drops below average variable cost, that means total revenue is less than the variable cost. In other words, the firm would not have enough revenue to pay all its workers. So if the price drops below the minimum average variable cost, then even the firm produces, the firm will not have enough revenue to pay all its workers. Now, no one wants to go to work without getting paid. As a result, workers won't show up. And therefore, the firm would have no choice but to shut down. The firm would not have enough revenue to pay all its workers. And if the workers don't get paid, they won't show up for work, and the firm must shut down the factory. So that's why when the price is below the shutdown point, the firm needs to shut down, because first, keep on producing, the firm will lose more than the fixed cost. If it doesn't even have enough money to pay the workers. Second, no one will come to work, and the factory must close its doors when workers not showing up to work. And now, what we have discovered is that short-run average cost, average variable cost, marginal cost. This is the starting point that the firm will start producing outputs. And the higher the price, the more output the firm will produce. And the output decision is where the price equals to the marginal cost. So in other words, how much the firm would produce is all resting on this portion of the marginal cost. So if the firm produces, then the output level that the firm chooses to produce depends on the marginal cost curve above the minimum average variable cost. So this section of the marginal cost is actually telling us how would the firm respond to different prices on the market, and it will vary the output according to different prices based on this marginal cost. In other words, this is actually the supply curve of this firm in the short run. Now, if you remember in the chapter, when we talk about consumer surplus, producer surplus, we said supply curve is the same as marginal cost. And now you know where it comes from. It's coming from the fact that the supply decision in the short run resting on this section of the marginal cost. And now, if this is the firm and this is the entire industry, and this is the marginal cost, starting with the shutdown price and the shutdown quantity. And now, remember the perfect information assumption. All firms have identical cost structure. And therefore, they must have the same marginal cost and the same response. If there are n firms in the industry, then we can figure out the industry supply in the short run. That is, when the price is at PS, then it would be all the way to N times small QS, which is capital QS. And now, why this is horizontal? The reason is some firms may or may not produce. At the shutdown price, some firms may produce, some firms may not, and therefore any quantity is possible. If none of the firms produces, we will be here. If all the firm produce, we will be here. If half and half, we will be halfway in here. And that's why it is any point is possible. And then this is just n times of the marginal cost curve horizontally. And this is the short run industry supply curve. Short run supply. Now, most of the time, when we plot the short run supply, we will ignore this part because rarely we will end up with a decision down here. And that's why when you look at the textbook, most of the time this part will be ignored. It's okay to ignore that in the exam. If you ignore this horizontal part, no marks will be deducted. But basically, this is what it should look like. And now, we need to connect the industry and the firm. So this is the firm's cost curves. And we have the industry short-run supply. And now, market equilibrium in the short run. If we have the market demand like this, in the market, demand equals supply in the short run, it determines the equilibrium quantity and the equilibrium price. So on the right-hand side, short-run supply equals to demand gives us short-run equilibrium, price, and quantity. And how do we connect this to the firm's graph? And don't forget, each firm is a price taker. It takes the short-run equilibrium price, P star, as given and sets marginal revenue equals to price equals to marginal cost to determine the optimal outputs to produce to maximize profits. So this is how we connect the industry to the firm. And using this, now with this as given, the firm would produce this level of outputs. And in this particular example, the price is equal to the short-run average cost at these outputs, and therefore the profit is equal to 0. And now, about everything we need to know about the perfect competition in the short run. And now it is time to extend that to the long run. And now, let's take a step back to Chapter 3. Chapter 3 says, increased number of sellers, increased supply, and therefore the supply curve shifts to the right. And now, the connection between long run and short run equilibrium. The short run equilibrium is where we have the short run supply equals demand. And the long run equilibrium, obviously, there must be a long run supply equals to demand. And now, what is the connection between the short-run equilibrium and the long-run equilibrium? So if this is a time horizon, this is a long-run horizon. And within the long-run horizon, there must be many short-run periods within the long-run horizon. And in here, this is the short-run equilibrium. And for the long-run equilibrium, that means any time within this horizon, you look at the market, this will be the equilibrium. And how is it related to the short-run equilibrium? So if any time you look at this market throughout the entire long-run horizon, you will see this long-run equilibrium. In other words, you look at this, at this point, it is this equilibrium. At this point, it is also this equilibrium. And therefore, this must be the same short-run equilibrium. And therefore, anytime you look at this long-run horizon, it is always the same equilibrium that you observe. In other words, a long-run equilibrium is simply a short-run equilibrium itself that is sustainable, period after period, and becomes the only equilibrium observed in the long run. Now, this is the connection between the short-run equilibrium and the long-run equilibrium. A long-run equilibrium is simply a short-run equilibrium itself, that it keeps repeating the same equilibrium period after period. And therefore, it doesn't matter where you look at this, anytime within this long-run horizon, anytime you look at this, it's always the same equilibrium. And now, what does it mean? If this is the same short-run equilibrium, sustainable, period after period, that means it's always the same short-run supply equals demand. That means if we have the same short-run supply, we must have the same number of sellers. In other words, there must be no entry and no exit, so that we have the same number of sellers. Now, firms will enter. Firms enter if this is a profitable industry, and firms will leave if they are losing money, because no one can lose money forever. So if this is profitable, firms will come in. If this is money-losing industry, firms will leave. And the situation in which no entry, no exit is only possible when profit is zero, no incentive to enter, and no need to leave. In other words, the prerequisite for long-run equilibrium to exist is zero profit. Only when we have zero profits, no firms enter, no firms leave, the short-run supply stabilized. And therefore, we have the same short-run supply equals to demand, period after period, to give us the long-run equilibrium observed. So, for an industry, in a perfect competitive industry, to reach the long-run equilibrium, this must exist, that is, zero profit. And now, going back to the definition of the long-run equilibrium. The long-run equilibrium must have the long-run supply equals to demand, but itself is a short-run equilibrium. Therefore, this must also true. And this is a condition for the long-run equilibrium to exist. That is, short-run supply equal to long-run supply at the point where also they intersect the demand. So that would be the long-run equilibrium. And now, the question is, how do we trace the long-run supply? Well, to do this, the easiest is to assume a constant cost industry. So what do we mean by constant cost industry? Increase or decrease outputs, increase or decrease inputs used, has no impact on input prices, and therefore all cost curves remain in the same position, whether there are more or fewer firms in the industry. So the detail of that, we will do it next week. That is, next week, we will derive the long-run supply curve for the constant cost industry. So let's stop here today. Don't forget, the tutorial follows after lecture. You're welcome. So if you have a question, you have 5 minutes to ask maximum, because I don't want you to miss the tutorial. You're welcome. I'll see you next week. Bye now. Take care. All right. Any question? Yes. Okay. Looks like no one has question to ask. Yes. Next lecture is chapter 13, Monopoly. So we will spend at most 10 to 15 minutes to wrap up chapter 12 next week. and then we will start chapter 13. You're welcome. All right. Any more questions? If no questions, then I will stop the recording and leave this session. All right, I'll see everyone next week.